Do you need a web application security solution that can improve your detection rate and enable easier remediation? Acunetics has a fully automated solution that can detect and report over 4,500 web vulnerabilities. Fast and scalable, it can scan thousands of pages without interruption, including HTML5, JavaScript, and single-page applications. Acunetics provides accuracy with the lowest false positives by combining black box and white box testing. For more information, visit acunetics.com/Security Week.
Welcome back, everyone, to our interview with Dr. Jing Xie. Before we get started, just one quick announcement. If you are interested in quality over quantity and having meaningful conversations instead of just a badge scan, join us April 1st to the 3rd at Disney's Contemporary Resort for InfoSec World 2019, where you can connect with and network with like-minded individuals in search of actionable information. Use the registration code OscarSierra19er-SecWeek for 15% off the main conference or World Pass. With that, Dr. Jing Xie is the Senior Threat Intelligence Researcher for Venafi, the market-leading cybersecurity company in machine identity protection. As a member of the Venafi Thought Leadership Group, she leads Venafi Labs, and prior to joining Venafi, Jing held research positions at FireEye, Lookout, and Hewlett-Packard Enterprise. She also co-founded a VC-backed security startup that uses blockchain technology to secure personal data. In addition to her research on iOS mobile threats, she's garnered worldwide coverage from some of her work. Dr. Jing Xie, welcome to the show.
Pleasure to be here.
Awesome. So first, I wanted to talk just a little bit about your PhD studies. Now, from our previous discussion as we were getting ready for the show, you actually studied in application security with a focus on static analysis. Can you tell us a little bit about some of your work?
That's correct. So my work was built up on static analysis. Back then, when I was in graduate school, static analysis was the dominant technique for finding vulnerabilities in software, including web applications. So what we realized, me and my team, mostly my advisors, we realized that it's really easy to find. Well, not super easy, but it's relatively easy to find vulnerabilities. But then there were tools such as Fortify, which I joined later after I graduated. It's relatively easy to find vulnerabilities, but where to go from there? A lot of developers still, make the same mistakes after they move on from one project onto another, or from one company to another company. So the problem actually remained. The way of thinking, our way of thinking was to push security or security awareness to the left of the life cycle, using modern popular terminology right now. So what we had was something relatively analogous to an incremental compiler in IDEs such as Eclipse that will constantly work in the background to compile programs such as the Java web application to find compiling errors such as lack of a semicolon or something like that, which will take a developer like 6 hours or even longer to debug and find. So what we had invented was a plugin that plugin for IDEs or that kind of environments that will constantly work in the background to find patterns of known bad vulnerable code and then prompt the users or the developers the vulnerable code. And also, in addition to that, we would give guidelines as well as quick fix, so that they can, when they're in the context of that application or of that chunk of code, they can actually pick up the security knowledge that's really relevant to the problem that's at hand, and also fix it, at a lower cost before the code or the vulnerability gets to the downstream to when the program is complete. So
that's awesome.
does it make any sense?
Super important.
Yes. So actually, I want to say something here. As far as the research was done actually back in 2010, 2011, 2012, which was the year I graduated. To this day, it's been, I don't know, 7 years. There hasn't been a lot of progress in that front, but I am aware of one of the companies that it's a European company that's been going towards that direction. I think it's called Hsms Security or Secure Code Warrior. They have embraced and adopted that thinking and started to put that into their product.
It's funny because their founder, Matthias Madhu, I believe was his last name, was our first guest ever on Application Security Weekly. So we're familiar with
so we used to work in Fortify together.
That's awesome. That's so awesome. And it's such a small world. I didn't know that from us speaking previously. So that's great. So for what we're here to talk about today, though, for secure code signing, I know that when we initially spoke, I had some confusion as to what that actually was and what the problem was that Venafi was trying to solve. So can you start by helping us to understand how is it that, especially the folks at Venafi and yourself, are trying to define what secure code signing actually is for the problem that you're trying to solve? Because I know that a lot of people can get very easily confused by what is meant by secure code signing.
You are right. You're right. You're not alone. There has been a lot of confusion in the market, even within Venafi, as to and in our customer base who are requesting for a solution. So when customers approach us, there were anecdotes such as they would be like, "Well, we have some trouble with code signing," and we're like, "Oh, okay, we are looking into this, and we think we have a solution for a code signing problem." And they would be responding with, "Well, okay, we're not sure. We've got to look at your solution and to see whether that's a right solution." So you see, there are solutions in the market, and in the market, and there are also we've observed a lot of a demand for a solution to a so-called code signing problem, but the demand and the supply, both sides are not really matched. So we feel like it's very important, and it would be very, very beneficial to really clear the air and the confusion and define the problem. So here's the thing. Well, can I ask you a question? What do you think?
Yes, please.
What do you think code signing is for you?
So as far as I understand it, right, initially when I was thinking of this, I was actually thinking of certificate signing. It was kind of the first way that I thought about it, because a lot of people talk, at least in the space that I work in, about self-signed certificates as opposed to certificates that are signed by an authority of some kind. Now, that's not really, as far as I understand it, though, what you're trying to get at, which is actually signing of a binary file, for example, with some sort of certificate. Usually it's like some sort of private certificate with a good root of trust, again, from an authority, to be able to validate that this is, in fact, like something that was built by the company and not something that is malicious. But I could be way off. So please tell me, where am I right and where am I wrong?
You are right, and you're right about some things, and you're not so right about some things. So
That's okay.
Code signing is you can use a public certificate, authority issued certificate to sign a piece of code or executable content. You can also use self-signed certificates to sign executable code. It doesn't matter where the certificates are from. So the code signing is oftentimes comprised of 3 steps. One is so you have an unsigned executable code or file, and then you use you hash it through a hashing algorithm to generate a one-way hash, and then you use a private key to generate a signature by encrypting the hash. and then you combine or assemble the unsigned content with the certificate that has a public key that's mapped to the private key that you use to generate the hash or generate the signature, and the signature together. Combine them together, and then you have the output, which is the signed version of the executable content. So that's code signing. The code signing was a security control that was invented back in the 90s because of the advent of internet. So all of a sudden, the software distribution in the past, and I guess in the 60s or 70s, it was done through vendors mailing out CDs or flop disks, to physical addresses. That kind of distribution model has had to be changed through relatively anonymous distribution from one online entity to a lot of other online entities. So all of a sudden, there is a trust problem where the receiving end needs to be able to identify and trust the distribution end. On the internet, as you know, there is no real good security or trust model. So PKI was invented as a foundation for distributing as an infrastructure to distribute keys and certificates that serve as identities for web services. So code signing is actually one of the applications of a PKI infrastructure. So the original problem was the recipient has trouble to identify and trust the distributor of the software. So code signing was to leverage the PKI infrastructure and allow that enables the certificate authorities to bind the identity of the distributor with a code signing certificate. And then the distributor can actually use the private key of their certificate to sign the to be distributed software and then put it on the internet. And anybody who downloads or receives the signed version of the software can have a legitimate way to validate the authenticity of the publisher of that piece of software. So that was for that purpose. And co-signing was able to guarantee two attributes or properties of security in this process. One is the authenticity of the publisher, and then the other is in the integrity of the distributed software. Nothing else. So that was in the 90s, and in practice, the implementation was mostly provided actually by operating system providers such as Microsoft, Apple. Later on in the mobile space, we have Android and we have iOS. And also Java virtual machine, so provided by Oracle. So the implementation was done very well, but it's what I call a one-man's job. So these providers, they provide utility tools such as Sign Tool provided by Microsoft, Code Sign provided by Apple, Jar Signer provided by Oracle. You just use it is a command line. It's a command line utility, and you just invoke the command line and provide the unsigned file, the certificate, as well as the private key to that certificate, where the certificate can be public trusted or self-signed, and then you execute that command, and then the output is the signed version of the file. So here you have to provide the private key of that certificate, which is possible and relatively straightforward for one person job, where this developer or user has access and ownership to all the ingredients for this operation. But things. Go ahead.
Sorry to interrupt. I was going to say that must lead, of course, to the problem that what happens when you're not a one-man shop, right? Like what happens when it's a situation?
Time. Yeah, exactly. It's so this kind of solution it's what I call single planked, bridge solution. You have this river and you want to cross from one bank to the other, and then you just put a single planked bridge, and you can get the problem solved. But in reality, especially in modern times, we're in the 21st century, the world has changed. In the enterprise environment, we have teamwork, we have collaboration, we have division of labor. All those ingredients are controlled and owned by different teams that have different priorities and different concerns. So in most cases, the private keys are not supposed to be in the hands of the developers. They're supposed to be in the hands of the security teams, or more specifically, the PKI teams, or some sort of secret operation team, I don't know. And then the unsigned files are under the control of the developers and other types of users, right? So you have this, at least, you have this kind of, fraction, in the whole workflow. Therefore, the single planked bridge solution doesn't work anymore. That's why we need something different. So there are coping mechanisms actually in practice nowadays in the enterprise world based on our discussions to our customers. So, by the way, Venafi serves Global 2000. So our customers are all big enterprises. We don't have a consumer solution or product. So we have very robust channels to the existing customers where we can get a lot of insight and information. So one of the coping mechanisms is you have these two teams, right? So on this side, you have the PKI teams. They're concerned about the keys, private keys and the certificates, and they deal with certificate authorities and PKI infrastructure and all that kind of stuff. And on this hand, side, then you have developers that are from all kinds of business units. They have different types of, they produce different types of software. Mobile, web applications, system level stuff, and all that kind of stuff. And they also have content that comes from outside of the organization. So one way, some companies, they're like, okay, so what we're going to do is to have the developers, when they want to sign something, they send their unsigned files over to the PKI team so that they can, get the keys and certificates and sign the files for them. So the signing actually happens here on this side, and then transfer the output to the business side or the developer side. As you can imagine, yes, that actually, in some sense, prevented the private key sprawling, and it controlled the access of the private keys, which is a very important asset in this whole process. I'll tell you more about that later. So you have control, but then the thing is, this team has no knowledge or context as to, very little context to what kind of stuff this side is asking for signing, and it's obviously it cannot be scaled, right? And then if the process, like on this side, everything is moved into, will be moved into DevOps, and everything will be automated. And this side is still very much, primitive, and is done mostly by humans. So the speed and the scale, they don't match. And that's a huge trouble for organizations. That's one, coping mechanism. And the second is, you reverse it, the process. So somebody on this side, developer says, hey, I have a file that I need to sign. I have a project that needs to sign. Can you give me the, corresponding private key and certificate for me to sign? And this side does some sort of checking, to make sure, okay, this request is not bogus. And then this will, this side, the PKI side, will actually hand over the private key and certificate to this developer side, and then developer side does the signing on this side. As you can imagine, one key can be, well, what is a key? A key is just a ASCII file. It can be read, it can be copied, it can be written. So this file can be copied and spread and distributed on this side to many places, and without tracking, without control, this side definitely has no control over how the key will be consumed and be distributed or secured, let alone be secured. So it won't.
I was going to say that's part of the security problem, right? Is it's a situation where once you've given the key out, you don't know who has it. And, let alone say someone, I don't know, they bring their laptop with them to a coffee shop to do a little bit of work and their laptop gets stolen. Well, guess what? If it's not an encrypted disk for some reason, or even if it was, logged into at the time that it was stolen for some reason when someone, stepped away from their computer, as by the way, seems to happen all the time on college campuses, which just still baffles my mind.
And it sounds like a perpetual problem. When we talk about vaulting technologies, your application might need temporary access to something that can expire. But when you're signing code, it's more perpetual than that, correct? Hence the more difficult problem.
Yep. So one of the major problems, there are several problems here, is the private key sprawling. Well, so it's quintessential for an organization to have control and be able to secure the private keys, and to not allow even one copy of the keys to be leaked out of a particular zone, right? So one way to do that is to use Hsms, hardware secure modules. There are vendors such as Thales. What's the other one? I don't quite remember. But we partner with several vendors, and a lot of our customers, they do have Hsms on-premise, appliances on-premise. The problem is, you can put the keys inside of the appliances, but the appliances, they are not built to support co-signing transactions, So there's a lot of things that are missing. I would say, upstream when the key, before the keys are accessed and used. So we have to build a lot of layers, several layers, in front of the HSM keys. And for code signing, so we are building a solution for that as one of the layers. So the other problem is, in addition to just like securing the keys, or control the keys in the vaults, in the HSMs, organizations, they need visibility and accountability to the signing activities. So you probably don't know, because this is not public knowledge, but organizations, there are quite some, they sign, the frequency or the volume of signing activities can exceed 1.8 million per month. So even with 1.8 million, that's a lot. If you think about one of the coping mechanisms is just it cannot be handled. So with that kind of volume, there are a lot of individuals are involved. You would want visibility, and you would want ways to characterize them, characterize them, to report them, and to first, of course, you need to track them for reporting, for auditing, for potential future forensics. So that the HSMs are just not capable, for this purpose. And then also, like I mentioned before, on this side, it's not a one-man job. It's not even, one engineering organization that produces one single mobile application that needs to be signed before it's distributed, like some mid-size or small companies. In big organizations, we're talking about a global 5,000, global 2,000. They have an array of business units, right? Each one will have, will produce different types of software, like I mentioned before. So you have, and each one, may have different, the projects or the products might have different sensitivities because they handle different levels of sensitivity of data. So they will need to be handled differently, and all these personnel that involved on this side need to be controlled and managed well with care. So role-based access control to the signing service or signing operations, where access of the keys is very essential for a effective solution for code signing. So code signing is not a problem. The code signing process is the problem. We're not here to solve the code signing. Code signing is already, it was a technology that was invented by the industry in the 90s, and the implementation was done already by, the PKI foundation and, the operating systems and the browsers.
So I know we're also running a little short on time, but I also wanted to ask a little bit about code signing for large volumes of files, right? I can imagine that's a whole other problem as well, especially if you have a hardware security module or HSM that maybe is either distanced from the team geographically. So now you're transmitting large files across the network. And things of that nature, not to mention, of course, large files by themselves, and the systems themselves might not be built to handle that kind of capacity. So to that regard, it sounds like, Venafi is working toward a solution that's both able to work with large volumes of files, but also is not necessarily locked into a specific regional location.
Exactly. So I hope that you've been able to get where I'm going. The keys need to be centrally controlled and managed. But the signing, which is comprised of 3 steps, like I mentioned before. First one is generate the one-way hash, and the third one is to assemble the signature that's already being generated, and the certificate and the unsigned file together into an output. So for these, since the utility tools that are provided by operating systems are very capable of doing this type of job, so we're not going to interfere with that process. So what I'm saying is the signing operation is actually going to happen in a distributed manner, while the keys are and the certificate management are going to be centralized and managed by the PKI team. So we have this sort of like centralized and decentralized model for the solution.
Awesome. And it sounds like it's something that's incredibly valuable, especially to your broad-reaching customer base of the Fortune 2000, which is really valuable to know that that's out there, because again, they need this sort of thing. Before we kind of wrap up here, though, Jing, we do have our 5 questions for Application Security Weekly, if you're ready.
What if I say I'm not ready?
Okay, I'm ready. Well, they are fairly painless, so hopefully we can get through them.
There's no wrong answer. Put it that way.
True. There is no wrong answer. So the first question we like to ask is, what were the specs like on your first computer?
Oh God. Do you want a short answer or a long explanation?
Short answers are great because we have a few more questions as well.
Okay, so the short answer is I actually have no idea. So I'm from a different country, and my country, the circumstance was different. I was brought up in a very let's say orthodox education, no background. So I wasn't playing with computers when I was young. I wasn't playing. I didn't even get to know computers until I got into college. So
That's
I
awesome.
went to the lab, and I was just given the ones that are used by. It was configured by some sort of admin. I have no idea.
So I want to say though, you would never know it just hearing you speak on these topics that are incredibly complex, firstly, and secondly, gosh, you must have learned a lot in that period of time, because you are clearly very, very smart in this realm of a number of things, right? Given your background and your history, especially when it comes to the code signing problem, but even before that. So hats off to you for that, because that's awesome.
Thank you. I also want to deliver a message to people that that are afraid of getting into this domain, which is very not friendly to certain. It has a certain culture. It's not very welcoming to certain groups of people. And me, as an example, being different, I think I wanted to think it's a good thing. It's never too late to do anything, and it's never too late to get into the application security domain or cybersecurity domain.
Absolutely. And I would wholeheartedly agree with you on that. The other question that we had as well, especially as you were getting into college, is what programming language you may have learned first?
Java.
Yeah.
So Java was the only language I used for a long time, actually for, 4 or 5 years. And then I gradually picked up all the other languages such as Python, Ruby, JavaScript, and shell programming, along the way, because there were problems and difficulties and just problems I need to address. There was no formal education on any of those languages besides Java, really. And one of the most interesting and the most the thing that I have been proud for a long time is something called Smalley. Have you heard?
No. Tell me more.
Smalley is an intermediate language for Android mobile applications. So when you do reverse engineering, you reverse the DEX content into DEX code into Smalley, and then you reverse all from Smalley all the way to Java code. Got it.
So it's similar to gosh, why do I always forget what it is? It's not bytecode. I'm sorry?
Assembly?
Yes, thank you. That's the word I was looking for. I always seem to forget that for some reason. So it's assembly for Android then is effectively what it is.
Yes, yes and no, but it's way easier to understand for humans than assembly.
Got it. Yeah, no, assembly is not a fun thing to play with by any means. So I do want to ask then, based on all the other languages that you learned, which one did you enjoy the most after, of course, learning Java?
Python.
Yeah,
I don't have a reason for you, but it's really intuitive, and it's really easy to. You don't have to set up the environment it's very prevalent, and when you first get your hands on it, you don't have to go through a lot of hoops in order to get your program run and see the results. You just follow the instructions online or in a book, and then you do it, and then you run it. You can get the result. I remember back then, a long time ago. Well, yeah, some time ago. When I first got into Java, there were so many configurations and so many things that you have to prepare in order to get your program. You have to write, and you have to compile, and then you have to run in order to see the result. And that was a pain in the butt. And that's actually discouraged a lot of my peers to not continue in this arena.
I totally understand. So and for me, I had to learn Java first as well, and then we got into C and C++, and I got much happier. Even though they still use the same compilation problems, but I liked C. Honestly, I think that for me, what it was is, and it may have been the same for you, the professor seems to make a big difference when it comes to learning programming, at least at the collegiate level, in my experience.
Totally agree. Yeah.
One of the other questions we have is specifically for if you ever used your preference between Vim or Emacs, but I'll also let it say that if you have a favorite editor that you really liked using, you're welcome to choose that one as well.
In the past, it was Vim. The reason was, when you have a new Linux operating system, you can access VI. So it's already built in most of the time. So it was really simple to get access to VI. And then, from VI, it shares a lot of shortcuts and commands with Vim. So I don't see a reason not to use that.
Right. Well,
at the moment, I learned later, no. So most of the time nowadays, I use PPT. Wow, I can't believe that. So I use PPT for most of my work, but in terms of coding and programming and that sort of stuff, Atom is actually a very good tool, I think. I like it.
Right on. So when you were coding as well, I always like to ask, or maybe even in your use of PowerPoint today, spaces or tabs?
Oh la la. I do both.
Nice.
Is there a distinction between the two? How do you distinguish?
Well, so for at least in the world of JavaScript, for example, and you may have seen some of this, they tend to use like 2 spaces, right? Whereas when it came to Python programming, some people will use like 4 spaces for their indentation, and other people will use tabs for their indentation, which if you're doing programming as a team and one person is using tabs for Python code and then you're using spaces, that will hinder compilation, or at least your ability to run the code, I should say, which is why we always ask.
Yeah, so most of the time I use spaces because I in the past I've done tabs before because it looks really cool and all the cool kids did that, but it generated a lot of problems, so.
Right on.
It generates problems when you move one program from one platform to another. For some reason, things just don't work anymore, and you have a lot of errors. Then they're very cryptic and mysterious. So from then on, I just stopped doing that.
Totally relate to that. Yeah, early on in my sysadmin career, it wasn't even code; it was like a config file, and tabs just totally hosed my whole setup. And then from then on, I was like, spaces for everything. It's good.
Yeah, exactly.
So the last question we ask is, and you've already kind of touched on this a little bit, but what sort of advice would you give to newcomers in the industry, or even people that are just interested in getting into the industry?
So at this moment, we've heard that there is a significant scarcity of talent for cybersecurity. So it's a good time. It's a great time to get in. That's one thing. Second is the space is growing. Cybersecurity is very exciting. There are a lot of subdomains within cybersecurity. There are a lot of aspects regarding or approaches that you can take to make things or our network, our software, our systems more secure. Well, no one solution is a silver bullet, and that's I think it's a good thing and a bad thing. So there are a lot of opportunities for one to contribute. You don't have to be a script kid when you're in high school. You don't have to be a coding monkey. For most of your a part of your life, in order to be good in this domain, cybersecurity, where from the defense perspective, it's all about risk management. in my opinion. So anything that the concrete approaches that we've taken, for instance, pen testing, static code analysis, secure architecting, and other types of forensics or other types of approaches, they are all geared towards a risk management objective. So everybody, I believe, I hope that everybody who has been doing security for a long time has already gained the understanding that there's no silver bullet. There's no one approach that can solve all the security problems. There's no one thing that you do and then you're immune to all kinds of attacks and security vulnerabilities. So I think the space is big, and there are a lot of opportunities. Just let the fears go and just do it.
I love it. Well, with that, Dr. Jing Xie, thank you so much for joining us on Application Security Weekly. And thank you everyone for joining us for another episode this week. Until next week, remember to git, commit, and stay classy.